Hello everybody, good morning. Myself Jose Matthew, your Jose. Today now I am going to explain you what is Fajans rule. A very important concept of chemical bonding. Fajans rule. You have studied and you know what are the differences between what are the properties of electrovalent and covalent compounds. Now, Fajans rule states the bonding in a compound can be electrovalent or ionic, but in that compound, some partial covalent character will involve. How these ionic compounds will develop partial ionic character, partial covalent character. To explain this, we need Fajans. There are 4 conditions you have to remember. One is small positive ion. 2, highly positively charged cation. Large anion. Highly negatively charged anion. Any of these conditions, if it is present in an electrovalent compound, then it will get some covalent character, covalent properties. As you know, from left to right when we move in the periodic table, the covalent character increases. See, ionic character is in the order just opposite will be the covalent character. Here the covalent character will increase and just opposite direction will be the ionic character. Because the size of the central metal or central element, it will decrease, and more will be the positive charge of the central ion. Say lithium 1+, beryllium 2+, boron 3+. So जितना ज़्यादा positive charge बढ़ेगा, ये पहला 2 कंडीशन अप्लाई हो जाएगा, स्मॉल cation and highly positively charged cation. Now, why this covalent character develop in the compound? To understand this, we have to learn the phenomena called polarisation. What is the meaning of polarisation? That is what I am going to explain now. Polarisation का मतलब है distortion of electron cloud. I will explain again. If we are taking Na+ and Cl-, right? The transfer of electrons took place from Na to Cl-. So the electron cloud will be moving more towards Cl-. तो Cl ज़्यादा नेगेटिव हो जाएगा. Sodium, because of its bigger size, it becomes more positive. It's positive only. Cl more negative हो जाएगा. That is why it's an ionic compound. It is highly soluble in water its melting point, boiling point are very high. That's what we are studying. Whereas if we are taking an ion like lithium plus, or we are taking beryllium 2 plus, or we are taking boron 3 plus, one plus is in a very small area, 2 plus is in a very small area, 3 plus is in a very small area, और साइज छोटा हो जाएंगे क्योंकि ये 3 plus. So smaller the size, more the positive charge. The positive charge density will be more. देखो Na plus में is bigger one. So 1 plus is in a larger volume. ये Na plus या K plus मान लीजिए. 1 positive charge is in a larger volume, larger space. तो डेंसिटी कम हो जाएंगे, पॉजिटिव चार्ज डेंसिटी कम हो जाएंगे. बट व्हेन वी आर कमिंग टू लिथियम प्लस या बोरॉन 3 प्लस या बेरिलियम 2 प्लस, द पॉजिटिव चार्ज इंक्रीजेस, द साइज decreases, so the positive charge density will be in a very small space here. और इनके सामने आया Cl minus. The electron cloud should go towards Cl minus. कायदे से यही होना चाहिए. But because of the more positive charge density, ये boron 3 plus or lithium plus will pull the electron cloud towards it. वाला ये पीछे की तरफ electron cloud को pull करेगा. Therefore, lithium ion सूरा में Cl minus है, मान लो इलेक्ट्रॉन क्लाउड इधर बीच में आ जाएंगे. And if the electron cloud comes between two atoms, it is getting some covalent character. So आने वाले आगे की तरफ जाने वाले इलेक्ट्रॉन क्लाउड को अपन लोग पीछे की तरफ पुल कर रहे हैं. That is what we say polarization. या distortion of the electron cloud. So polarization power अपन 5 से डिनोट करते हैं. देखो इनमें से 4 कंडीशन आप अपने दिमाग में लिख लो. Ionic charge upon ionic radius, the whole square. So more the polarization, more will be the covalent character getting in the compound. Even though bonding is electrovalent and ionic, the nature जो है some covalent character develop होगा. If you are taking the melting points of NaCl and you are comparing it with the sodium iodide, iodide is bigger as compared to Cl minus. This Na for NaCl will be more ionic, more will be the electrostatic force of attraction. But what about NaI? Iodine is bigger in size, large anion, more will be the polarization, more will be the covalent character. So melting point of NaI will be less, whereas the melting point of NaF, KF or NaCl will be high because they are having more ionic character. इसी तरीके से if I am taking here, अगर आपने लिया lithium chloride, I told you it is partially covalent. The nature I am talking, थोड़ा सा covalent character होगा. So this will be partially, sparingly, मतलब थोड़ा सा soluble in water as well as in alcohol. अगर आपसे पूछते हैं why lithium chloride या lithium salts are sparingly soluble in water as well as they are sparingly soluble in alcohol. You will say because of the smaller size of lithium plus its polarization will be more, so it will develop partial covalent character according to which rule? Fajans rule. मेरे बच्चों इसी तरीके से अगर मैं आपको बोलूं, अगर आपने लिया एल्यूमिनियम क्लोराइड एंड NaCl, देखो ये Na प्लस, ये एल्यूमिनियम 3 प्लस. The space, the volume is less, so positive charge density will be more. So AlCl3 get partial covalent nature. Whereas NaCl, you know, it's a purely covalent compound. Sorry, ionic compound. NaCl is purely ionic compound. अगर इन दोनों में आप कंपेयर कर लें the conductivity, which will conduct more electricity, definitely NaCl will be a better, good conductor in solution as compared to AlCl3. Why? AlCl3 develop partial covalent character because of the smaller size of aluminum 3 plus, polarization, distortion of electron cloud take place. So Fajans rule is basically to explain why some electrovalent compounds develop partial covalent character, why their property, they are poor conductors of electricity, why are they develop covalent characters, so why they are poor conductors of electricity, why their melting point, boiling point are less as compared to a very good ionic compound like NaCl, KCl, etc. Thank you very much.